In this next example on differentiation of logarithmic functions, let's take a look. You are given this expression by taking natural log on both sides. They give you already a hint. Find the exact value. Exact would suggest that you cannot use GC. Alright, because if they didn't say exact, don't waste time, just go to GC, key this in, and that's it. Alright, make y the subject, key this in, and then you can use GC. But exact suggests that you cannot use GC, and therefore we have no choice but to, they already tell you by taking natural log. So we take natural log, and basically you take ln on both sides. Take ln on both sides. Alright, so take ln on both sides, you get that, and then you use power law to bring the cosine x down, you get that. Alright, then what do we do? They already give you a hint like that, then it's fine, we will deal with it using implicit differentiation. Alright, implicit differentiation. Alright, we will use, then we will get differentiating with respect to x, we get this, you use, this is product rule, from here to here is product rule. Alright, keep cosine x, differentiate ln x, you get this. I repeat, differentiate ln x, you get this. And then differentiate cosine x, you get negative sine x, and then keep ln y like that. And then you have a 1 over x. Now, it may look complicated to you, and let's begin with n in mind also. You are required to find the value of dy dx at a particular x value. But two things I want to say. One is you look at the expression here, your dy dx contains both x and y. Second, as long as you can find x and y, you just dump it inside and you can find dy dx. So there is no need to spend extra effort to make dy dx a subject. And point number one is in terms of x and y, which means while I know what is the value of x, I need to find what is the value of y. So at this point, I want to find what is the value of y when x is pi. Okay, when x is pi. So therefore, I'm going to write when x is pi, then what? Then y cosine pi is actually pi. So I'm substituting, I'm using this one here. Alright, so my objective is to find what is y. So cosine pi happen to be minus 1, and therefore y must be 1 over pi. Okay, so we know that when x is pi, y is actually 1 over pi. So I'm going to substitute this pair of values into equation 1. So I will substitute this pair, this one, and this one into equation 1. Not difficult, it's just a simple substitution. Pi in, 1 over pi in, pi in, 1 over pi in, pi in, and you simplify. What do you get? Now cosine pi is negative 1, so we have a negative 1. Yes, 1 over pi, you get pi dy dx. Sine pi, you actually get 0, so that this term is 0. Therefore, your dy dx, you get a final answer. Divide both sides by minus pi, you get 1 over pi squared, and you have an exact value. That's that.